Cool, great. Yeah, so Milos, my name. Great to meet you. From Deepset, I'm not gonna dig too much into the company. We have a booth here. Happy to meet you afterwards there. We also will have a demo over there if you want to learn a bit more about, in specific, what we're doing. But the focus of the presentation is pretty much to talk a little bit about enabling enterprises to adopt NLP. And what I will guide you through is, let me briefly do a very brief overview of the state of NLP, not just with regards to models and research, but maybe in general, how do people build with it. We will then go into the common challenges of adopting NLP, and I don't want just to talk about the challenges today, but also show you a little bit of ways and mental models how to approach it and how to solve these challenges. And then let me illustrate that also alongside a case study. And yeah, I'm happy about any questions, and I hope I can answer all of them at the end of the talk. So let's dig into the state of NLP. And I mean, Mark already flagged it a bit. There are a lot of terms around these days. So large language models, BERT, transformer models, a lot of things happening, a lot of excitement around that. Where does this excitement come from? What is the reason? Why are we thinking today about NLP so much? Number one, because it actually works now. So this is probably not obvious, but these modern models and architectures, they really work, and they can be applied very fast to a variety of use cases. The second thing is, there are effective strategies to tailor and tune these models to specific needs. For example, what if the NLP model doesn't understand particular terms or abbreviations? How can I get that into it? And this is now also very effectively possible. And the last thing is, it's available, so we can access it. There are many open source opportunities to use and get familiar with models, but also, of course, commercial APIs that are driving the accessibility. And all of this is not just fostering interest, but also fostering the actual adoption. So what is it now where NLP gets adopted, especially in the enterprise setup? The use cases are probably endless, but to give you like a little bit of an overview, one big category, definitely document and data processing. For example, in financial services, where we see many banks, companies, funds in risk management who have to deal with a lot of data around individual companies, and their analysts in the end need to extract very specific information out of it to assess the risk profile, to maybe make a certain decision. That information can be how high was revenue, how did profitability evolve, what are core risks, what's the hedge against COVID, stuff like this. Another big application is in this whole space of search and knowledge management. Enterprises invested a lot over the past years to get to very rich knowledge bases, wiki systems, data lakes, tools like Confluence have been widely adopted. Now the next step is to improve the accessibility to the information stored in there. For example, maintenance companies that have a lot of technical handbooks, technical documentation, past project records, best practices, how to solve certain problems, and now enabling their, for example, maintenance workers on a day-to-day basis to find information on how to fix a turbine failure, how to solve error 404, what to do when I get this error message. And the last big category, you were talking about chatbots, Mark, virtual assistants, they are around. I think we can make them now even smarter, so to say, or more capable. We can actually increase also the amount of questions they can find answers to today. And of course, one common application is retail. When you think about, I don't know, what are payment terms, what are how long is the period in which I can send back the good after I ordered it. All of these questions can now be answered also on a way broader scale. So how do enterprises build NLP applications? Let's briefly look at these teams and stakeholders. I think it's important to always think about the fact that NLP is usually a very powerful functionality in a product. And this means that it should be treated as part of a bigger product. And this means we need someone who owns the product. And these products, chatbots, search engines, and so on and so forth, are usually products are always built for the business lines or end users, right? So the first thing of every NLP product should always be make those people who have the requirements and who want to use the product, make and let them experience the capabilities of NLP. What can it do for them? What do these models, do these NLP applications actually at all provide the output that they're expecting and that they are needing to work with? And the second thing is the business line and the users need to be involved not just at the beginning to specify requirements and in the end to accept the application, the product. They should actually be involved alongside the whole product lifecycle. Now, if we go to the engineers, there you see engineering implements the product, right? But a product that is powered by NLP consists of two different kinds of engineers. On the one hand, we have the NLP engineers, the machine learning engineers, data scientists who are responsible for the modeling piece, so the actual NLP model. But then there is a full stack application that is required, right? We need to serve data to the model. We need to somehow be able to use that NLP functionality in a bigger application, in a bigger product. And this is actually where a lot of struggle also often can happen. So what needs to happen is we need to enable some or both teams to work together and enable actually this building a model into an application. And again, both teams have to continuously find ways to get the feedback from the business line. So it is a core responsibility to make sure not just that the full application product is in line with what the business wants, but also is the model quality sufficient? Does that make sense what we get out of here? Again, is there a value in the output for the business line? So, sounds easy, but it isn't. Now we're moving into the challenges. Yeah, the product owner, to close it, probably lucky, unlucky, in the middle, bridging this, translating the business requirements, but not just being responsible for actually the implementation success, but also the business success and ultimately the user acceptance from the business lines. Now, what are the common challenges here? Number one, the data science teams usually start with the challenge and the question of where do we or how do we actually get to a model at all, right? And I think Mark already mentioned it. This is the beauty of modern NLP today, that we do not really need to take care about training right away. We can get started with a lot of capabilities that are out there. This means companies like Google, Meta, OpenAI also, they're the ones who invest heavily in training these models, and they also make those models available. So most of the best performing models are actually open source. We have also proprietary versions of that, but also those models, they are there. They can be used and they can be consumed. So this means there is a very easy and fast access to NLP capabilities that can help us to get started without immediately thinking about where do I get training data from, where do I get the compute from, how do I solve these challenges. The second thing is that the whole product team actually has to think about NLP functionality as an application in itself. What do I mean with this? Think about a question-based search. So now you have a model that can find answers in text. This model is in the end only one single component. It is not the full application. So that's quite obvious, right? Because first question is how should the end user access the model capabilities? But actually it's not just the application layer that is, so to say, the user interface that the end user business line is using. And it's also not the data this runs on. Actually, you see that in between, there are many steps that need to happen to enable this functionality. For example, you have to somehow pre-process the files that you actually want to perform the question-based search on. And once you did that, you have to put them in a kind of a separate store and save them there. And then you usually won't have just one model to solve the use case and serve the business application. So in this case, you probably build in a filter retriever model, and then on top you have this question answering model. And now you see that NLP functionality is not just a model, it is an application, or how we call it, a pipeline. And the last aspect is there is not much experience around how to properly work, let's say, in the product lifecycle of NLP applications, because some paradigms around how to build these applications are different. To bring some things together, we talk now about the model is not the full solution, right? So let's not start from the model, but let's start from the pipeline. What is the full pipeline we have in mind that should solve the use case? What we do then is we prepare this pipeline, and then we can start to pick models. Which of the pre-trained options out there we want to use? Which ones do we want to see and evaluate? And then the next step before you do any training is actually evaluate these pre-trained models. And you do this twofold. On the one hand, you do it with test data, the classic data scientist and machine learning approach. But as NLP is so end-user centric, so I like what Mark said, because so much goes into NLP, because NLP, you know, as the capability of machines to understand language, can actually be used literally everywhere and by everyone. You really need to make sure that this end-user feedback is also happening in the same time you do your, let's say, gold data theoretical evaluation. And based on those insights from evaluating with users, with test data, you will see, first of all, do I need to train and fine-tune at all? And if, what actually should I improve the model on? Is the model struggling with my abbreviations? Am I in the biomedical domain and it simply doesn't get the molecular names? All of these things help us to define very effective strategies for fine-tuning or training, and then we can deploy, and then, you know, as it is the case with each and every software, we run through this life cycle probably over and over again. So how has this been implemented? And let me briefly guide you through a case study here. So the case study here is a financial services firm who improved their IT knowledge management. So we talk about a Confluence wiki, and what is in there is a lot of guidelines and so to say past project records, how to behave when developing software. The business application, so to say, in this case the business user and the developer, you could argue, are a similar persona, but still the business application is to build this into an intelligent search function that is accessible via the internal company wiki, and technically it's solved via using semantic search, NLP powered, with question answering in it. And you see here a screenshot. I'll make a try and see if I can bring up the browser, because I can also like just demo it. So give me 1 sec here. Hope it's going to work. Let me see. There was something going on. Okay. So I hope you see this here. Oh, that's now hard. Can someone tell me, are we in the right? No. So we can now ask, for example, I don't know, what is the log retention policy? And here's a question mark. I hope I typed in everything more or less correctly. And then we get, what do we get here? Can someone tell me? 90 days? Okay, I think that's a reasonable log retention policy. And this is in the end how this application now looks like. Cool. So going back into the slides and starting again here. Now I have to restart it again. So what they did in the end is they went through this life cycle, so to say, once. This means they started by thinking about, okay, for this end use case, for this scenario, where an end user is sitting there and typing in these questions, what is the pipeline I will need? And this was the first step. And moving from there, what they did was they started exactly this evaluation of pre-trained models. So what happened is they built a demo application, they shared it with the end users, they collected some exemplary questions and answers that would have been expected. And what happened then was they ran evaluations on this. You tried out different models. The model that won in the end is a Roberta Squad 2.0 for the large model for everyone who's more into the tech parts. reached an accuracy of 85%, but still felt like it's worth considering to boost that. So 85% means the first result that the pipeline gave back was a satisfying one for the end users. And now what they did is they created a set of training data. So the strategy has been derived. It was mostly around, I think, security policy terms that required some improvement, something that the pre-trained model probably hasn't seen or been trained so much on. So this was the very narrow strategy that has been driven. They created 2,000 labels. Sounds a lot, but it's actually quite fast to generate. It took 8 days, and you don't need to be any domain expert for doing this. Trained the model, rerun the experiments, and in the end ended up with a user acceptance beyond 90%. And this was satisfying enough to actually say, okay, we moved this and shipped this into production and launched the full stack application then with availability in the beginning, of course, for a smaller set of users. So we talk about 200 users here, but with the opportunity or with the vision to roll this out to the whole IT department of more than 10,000 developers. That being said, first of all, if you have any NLP use case and would like to get simply our intel on it, how to approach it, how it could fit the cycle, please feel free to either scan the QR code or take this, type in the URL. We will have a demo on some things, so how actually NLP can be used, and how applications can look like in our booth at, what time is it now? It's 12, so at 1, I think. So please come by our booth and meet us there. And also, if you cannot make it to the demo, of course, come by our booth. We are around the next 2 days. I would love to get into some conversations, learn a bit about if you're building with NLP, what you think about, just exploring, seeing if and how we could be helpful. And with that being said, I'm happy to take some questions. And yeah, here's also our website on Deepset AI, so also visit us. And
yeah. We do have a couple of minutes for questions, and I'm going to lead off because I'm a pig on that. I like to ask questions. So, Milos, if you haven't figured out already, he's a data scientist. I mean, that might not have been obvious, but I was interested in something you've talked about before. You mentioned working with Siemens. I don't know if you could talk about that, what you're doing with them. I think that's really illustrative of how this evolves, right? So can you talk to that just a little bit about what it is that they found with what you're trying to help them with? Was kind of cool.
Yeah, of course. Happy to briefly talk a little bit about what Deepset actually does and what which levers we, so to say, provide. So we are the authors of Haystack, which is one of the probably best adopted NLP frameworks out there. It's an open source framework, and what Haystack does is it actually enables you to build these pipelines. So this means it's technology agnostic in the sense that you are not tied to one model, but what you do is you simply set up the pipeline first, and then you pick up the components that are most suitable for you. If you want to experiment over different models, that's then something you can do. You can just pull them in the Haystack framework. In the past, we did a lot of services, and our services mostly supported or actually helped us to understand how we should help customers to build with Haystack. And from that, we derived this life cycle. So this was a lot of consulting and support in the past, and is now part of a platform that we're offering, which is called Deepset Cloud. And on Deepset Cloud, you can actually walk through this whole life cycle from designing pipelines, experimenting and evaluating, getting feedback from end users, performing the fine-tuning, deploying, of course, as well, and going over and over again. So to say, we are on the vertical side of the tech stack, but also on the horizontal side of the process and workflow to adopt.
And one of the things he mentioned to me, what I was going for is he's helping them, so they figured out a way to kind of scrape through all of their information to find all the data that they needed to hand it to somebody to say, well, we're building this, product manual, or we're doing these things. So it helped them pull all that into one place, which was the end result, was pulling that together. You had a question.
Yep. So you talked about the success, 85% pre-tuning and then 92.5%, I think, post-tuning. Yeah. How are you all measuring success here? And then kind of maybe an important question as well is, what was the volume you were looking at? Because I imagine how you evaluate success is kind of dependent on volume in some way.
Exactly. So the success is the first response useful to the end user? So we took the theoretical metrics like F1 score a little bit as a guidance, but we really made sure that it's a purely end user evaluated evaluation, mostly because, that's not a bit technical, but we realized that in these gold eval data sets, people tend to say, well, that is what I would expect to this question. But it might be that the same thing pops up multiple times in a document base, or, honestly, that the NLP models are actually getting back more suitable answers that the users often were not aware about when defining this gold data set. So this is why we said, okay, we use the theoretical data set to get a feeling and to support it a bit with metrics, but when we saw this is stalling, we just relied on a pure end-user-centric evaluation. Or the exact numbers, I think we had 15 users and each of them evaluating 300 to 500 questions, I think. So yeah, but honestly, to get an initial feeling and to get started, that's not what you have to do. If you really want to move into user acceptance tests, I mean, if you really feel like, okay, we want that last security, that's what you should do, of course. But to really get started, to get something going, just build a demo, throw it at people, see in general, is this what they expect? Is the product experience something that helps them at all? And then you can go down the rabbit hole and see, okay, where does it need improvement? Where doesn't it need improvement? Well, that's like a little bit like this. And then there are different flavors. You can make it very lean. You can run proper A/B tests. That depends a bit on the resources as well, of course. In this case, it's a tool for more than 10,000 developers, so we had some access to some folks.
Got it. One more question? Anyone? No more questions? Oh, there we go.
Hi. Question, how far are we away, in your opinion, from one of these universal digital assistants that we can use, regardless of device, regardless of all these things, that uses NLP to kind of, help you out on a day-to-day, not just like, okay, I just want to do search or I just want to do Alexa or something like this, but something more ubiquitous. If you had to project, just based on how fast the technology is moving and how the adoption rate is going, what would you say for that? And then follow-up questions, since I'm a little bit on the hardware side, is there any hardware challenges or constraints with implementing these types of models? Is there something that, a bottleneck on the hardware side that could be cleared?
Two exciting questions. Let me really start with the last one. There's never a limitation on the hardware side. There's only a cost limitation on how much hardware you can afford. So the hardware is around to make things use. It's just simply, it can be very expensive for sure. So I think, then now I go back to my first question, then I get back to your second one. So to your first question, then I go back to the second one. So models themselves, I don't think that this is the challenge, and probably the architectures today are very mature and very good. They're very big. Okay, we can make them bigger. All in all, these models are very mature already, So I think we can have a lot of comfort with this to move really into, let's say, maximum capabilities using these things on a day-to-day basis. The limiting factor is usually data. So when you think about an application like, I was talking earlier about risk management in banks, right? So financial services is one of our it's the biggest customer segment we're having. And in financial services, of course, you have risk reports, and then there are terminologies that are specific to Solvency II, or maybe even company specific or whatever. You somehow need to induce this, right? You cannot have a model that has seen that data, because in a world with privacy, that data will always be private. Let me give you a more haptic example. If you think about a personal assistant on your smartphone one day, and you're asking the assistant, what's my credit card number? Again, in a world with privacy, the model needs to have access to this data somehow, right? And this is why I think models, these data integrations, yeah, I mean, that's a little bit also what we do at Deepset. But then we come a bit into a compute topic, because if you think about assistants on personal devices, then it's a lot about which loads are moving to the cloud, which are happening on device. Does a fine-tuning happen, for example, on devices, right? And in that moment, I think probably we're not yet there to have really the full hardware available that is needed to really make this, individualized fine-tuning possible, so to say. But yeah, these are my thoughts around it. Yeah.
Thank you, Milos. Appreciate it.
Thanks.
All right, give him a hand.